All right, hello everybody. So what I'm going to go over today is how to install and what are some basic level functions of ChemPy, which is chemical engineering tools for Python. So you're able to access stuff like physical properties, solve basic stuff like balancing an equation, and a whole multitude of other things to be added later on down the line. But those are the three basic things that can be accomplished as of today. So our first step into installing ChemPy is you need to come over here to the Git homepage, click on this link, download it, extract it, run the executable, and now add Git to your computer. And once you got that, make sure you have pip enabled. So open up your command prompt, type pip, and you should see these commands pop up. So just to show you, if I type in pip in my terminal here, it'll pop up all of these. So you get commands, options, all that. If that is not occurring for you, you have to go to where you installed your Python, rerun the executable, and make sure you click add to path and enable pip. And so once you get all that squared away, you're going to copy this link, right, or this command right here. Go back to your terminal. I'm going to hit clear real quick. And then, well, before you do that, one thing you should do is make sure you have wheel installed. So hit pip install wheel, which I already have installed. Then once you do that, run that command. And then what will happen there is it'll collect, do all that stuff. I already have ChemPy installed, so I won't go through the whole thing. Excuse me. But to show you what it does, let me just uninstall it. And as you can see, it just builds a wheel, creates it, then stores it. So when you go up here, what should happen, if you type in import, you should see ChemPy pop up. Now, some other packages you need to install before it'll work correctly is you need to install CSS, stands for Cascading Style Sheets. That's used for mainly HTML and those kinds of languages. Select. Make sure you hit install. Then already you have it installed. The next thing you need to install is request HTML. So it'll be requests -HTML. And I already have it satisfied, so I'll just run through and make sure everything is installed. Then the last thing you need to install is pandas, which is already satisfied again. So with that, the first thing we're going to go over is compound. So if you type from ChemPy.molecular properties import compound, what compound is, it basically allows you to store all the information related to a single element or compound into a variable. So start off with, for example, ethanol. Do compound ethanol. And say you just want to know as much information as we want to know about it. So if we run this, now one thing you should know is if you have not run request HTML before, it's going to install Chromium. So you'll see red text appear down here. You'll see a status bar saying downloading Chromium. Once that finishes, the rest of the script will run. So starting at the very top, you have its name with its ethanol formula, C2H6O, or if you want to do in the organic way, be CH3CH2OH. It has molecular weight, X log P3. You just keep scrolling down, and you see all these different properties. So boiling point is 173.3 degrees Fahrenheit. Melting point is negative 173.4 degrees Fahrenheit. Flash point is 55. Solubility is 100 milligrams per millimeter. Density is 0.79 related to water. So it'll be 0.79 the density of water at a given temperature. Vapor density is 1.59. Same logic against water vapor. Now you see millimeters here, that stands for millimeters of mercury when dealing with pressure. Then you sort of see these NAs down here at the bottom. So the reason those are NAs is because they are not available on the site that this package uses. So what site this package uses is the PubChem site. So for example here, as molecular formula, then all of these are recorded. So like boiling point was 173.3, melting point was negative 173.4. But as you notice, there is no standard heat enthalpy, no sigma constant, no epsilon constant. So since those are so varied by different sources, they aren't really available outside of textbooks. So one thing to account for that will be to set, for example, that value. So set standard enthalpy, do the value, then that standard enthalpy, I don't know it off the top of my head, but for example, it could be 273.05 kilojoules per mole. And so when you do that, you only want to look at, say, PHF. Let it run, print out negative 273.05. Now the cool thing about this package is it saves these readings onto your computer. So for example, say you are working with ethanol a lot. You need to run another script somewhere else on your computer, but you're using the same library, the ChemPy. So with that, one thing that you can do is, even though this is not setting anymore, if you run it, it'll still pop that up. That's because what's happening is it's saving all of your logs into a CSV file on your computer, MISC properties. So it saves all that on that CSV file, and it pulls it up every time you reference that element or compound. Now, if you're working with multiple compounds or elements, so like propanol, carbon dioxide, let's shorten that to CO2, and say you want to compare the molecular weights of all three of those. So ethanol dot molecular weight, propanol dot molecular weight, and CO2 dot molecular weight. So let it run for a bit. You get 46.07 for molecular weight, 60.1, 44.009 carbon dioxide. Although they don't have any units with them, they are all in grams per mole. So now that we have an understanding of how to use the ethanol, propanol, and carbon dioxide, our next area of interest is going to be reaction series. So a reaction series is just one side of a reaction equation. So for example, so I comment that out real quick. Oxygen pound oxygen. And then water compound water. When you type in these element or compound names, make sure they're all lowercase. Otherwise, some of them will not work, some of them will. So it's best practice just to keep everything lowercase. So what happens when you combine ethanol, oxygen, ethanol, and oxygen is a combustion reaction. So that's one side of an equation. So I'll call this reactants, RxnSeries, ethanol, oxygen. Then just show you what it looks like. We're going to print reactants out. Oh, forgot to have you guys install one more package. Pip install ChemPy. No, ChemPy. My bad. So ChemPy is just a thing sort of like NumPy and Pandas, where ChemPy is much more symbolic, hence the SY. So with ChemPy, it has stuff like matrices, arrays, stuff along those lines. So if you run this again, you can see ethanol, the formula for ethanol, C2H6O, plus oxygen, O2. And so do the same thing with the products here. RxnSeries, CO2, water, print products. Run this again, give it a little bit. You see ethanol plus oxygen in your reactants, carbon dioxide, dihydrogen monoxide, water in your products. So now that we have a good understanding of how a reaction series works, then if you ever need to look back, reactants, you have two attributes here, compounds, which will be ethanol and oxygen, if you ever need to access those again, into formulas, which is the C2H6O, O2. Just before we move on with that. So the next thing we need to worry about or talk about is reaction equations. So there are two ways to do a reaction equation. You can come up here and import it. And when you import it, what happens is same thing as before. It's a class, so you make an instance using parentheses. And then you need two lists, one for inputs, one for outputs. So reactants, say you want to do ethane or methane, so CH4 and we're going to do another combustion reaction, so O2 for oxygen. Then same thing here, CO2 H2O. So if you do that, two things you can do. You can print the equation, which will just show the overall equation. Keep in mind it will not include coefficients for a balanced equation. To view those, what you have to do is EQ.coefficients. Now what happens is when this instant is called, it'll calculate the balanced coefficients for each of these. So separate by break line. So I'll let it run again. And as you can see, CH4 plus O2 goes to make CO2 plus H2O. The coefficients are as so: 1 mole of methane plus 2 moles of oxygen create 1 mole of carbon dioxide and 2 moles of water. If you just undo the quick math, we have 1 carbon on this side, 1 carbon on that side. 4 hydrogens on this side, 2 times 2 is 4, 4 hydrogens on that side. Then 2 times 2 is 4, so 4 oxygens plus 2 oxygens plus 2 oxygens. So that's one way you can call a reaction equation. Now the next, so I simply call in the reactants first, using the star or multiply symbol, then products. Now if you print that EQ and EQ.coefficients again, let it run for a bit, and what you're going to end up seeing down here is, just as before, we have 1 mole of ethane, or ethanol, plus 3 moles of oxygen, make 2 moles of carbon dioxide and 3 moles of water. Same thing, going to go through, we have 2 moles of carbon, 2 times 1 is 2, so I have 2 moles of carbon over here. With hydrogen, we have 6. 6 times 1 is 6. Come over here, 3 times 2 is 6. So we have 1 oxygen plus 3 times 2 is 6, so that's 7. 2 times 2 is 4, so we have 4 oxygens plus another 3, which is 7. So you can see it's fully balanced out. And with that, that's going to end our first part of this tutorial. In the next upcoming parts, we go over each different subdivision. So the so we go over like the system solver, the figures, data conversions, and briefly touch on the engineer solver, because that's one part that's still a big work in progress, which we'll be able to go more in depth in about 2 or 3 weeks maybe. But overall, our next video will probably be on, for example, data conversion, and sort of like how to get from the properties into a data set, and then sort of how to work with that data set. But with that, thanks for taking time to watch this. I hope it helped, and I hope you guys get a good use out of this package.